I set a personal record for number of firings with this piece of Alpha Munitions brass. In this video, I'm going to talk about how many firings that was, what the cartridge is, and how I accomplished it. Hey guys, Gavin Gear here from UltimateReloader.com. This year has been a really fun year of experimentation and generally pushing things to the limit here at Ultimate Reloader. We started out by pushing 308 Winchester to 300 Win Mag. That was a story with Alpha Munitions brass. We did an extreme torture test of that same 308 Winchester brass, and recently took the 6GT and pushed it to 6 Creed performance. So what I thought would be a good next step would be to take 6 Dasher brass and to see how many firings we could get at max load, and that's exactly what we're going to cover in this video. Let me first show you my loading process and the steps that I went through for each firing of the brass. So one of the things I'm doing differently this time is between firings, I'm annealing the brass. I did not do that when we did the 308 Winchester torture test. So I've got the Annealing Made Perfect Mark II DB, and before we do any annealing, we need to generate a code. And we do that with Aztec technology. And so we can hit Analyze on the machine. This is a number 52. And so we just put the case in. This is going to be a sacrificial case. Hit Start Analysis, and it's basically going to bring this piece of brass to the melting point, but not completely melt it, right? So, wow, did you see that? It was actually glowing red. You can see a little bit of distortion here. We have an annealing setting of 146, and we're just going to say use that now. So we've got our analyzed case set aside. We've got our code entered. This is a piece of brass that I've fired one time. And so we just did that. We're going to go ahead and anneal. Okay, now I'm going to take this piece of brass and let it cool off. So the case has now cooled enough to be cool to the touch, at least not more than warm. So we'll go ahead and apply some case lube to the inside of the case neck, the outside of the body. We're set up to size here. Very carefully set up the sizer so that we weren't oversizing the brass each time, a pretty important component. Wipe off the lube. So we need to reprime now. And I've got the charge just set and ready to go as a manual throw here, no trickling needed. Grab a bullet, index our seater into position, and seat the bullet. Okay, so now we go to fire it. It was snowing and raining when I went to do this test, so I decided to do the shooting indoors. Kind of nice to have that ability. Okay, and aim at the same spot for fun. Make sure I don't lose the brass on the floor. We don't want to dent that case neck. Keep a little bit of the heat in. So basically it's a 3 to 4 minute process when you count for the annealing and the cooling. And then after each firing, I also took a picture of it with the counter indicator for the number of firings. So that is the process for each firing. So for this experiment, the approach with the load data was real simple. It's just use a max load, and we're going to use that max load for as many firings as we can until we get some sort of failure. So don't use this load data. For reference only, what I was using was Hodgson Reloading Center data for Varget and the Alpha Munitions small rifle primer 6 Dasher case, which I started with a brand new case. So the max load was 31.8 grains of Varget with a Berger 105. We really like these Berger 105s. And 2.459 inches cartridge overall length. And so we went through the process, started at 0 firings, took a picture of the brass, and then kept firing, and occasionally I would take a case length measurement to see where we were compared to a brand new case as reference. And when I got to about 15, 20 thousandths over, I would do a trim. So trim number 1 was at 19 firings. Trim number 2 was at 36 firings. Trim number 3 was at 47 firings. And trim number 4 was at 68 firings, if you can imagine that. So we had quite a bit of brass flow over the course of the entire experiment. And I just kept going and kept going and kept going. And I would occasionally clean the neck of the case. This is the actual case right here. And with a Scotch-Brite pad to look for cracks or other signs of fatigue or problems. And what was interesting about the experiment was we had a failure just between one and the next. There wasn't any kind of signs ahead of time, maybe the slightest line on the case, but at firing number 76, in the shoulder area, we had a giant crack show up. So we probably had a bunch of gas leakage. Now with the brass in the chamber, you know, swelled into position, it might have been kind of buffered by that, and the leak might have been very minimal. But 76 firings, I believe this is 62% more firings than we got without annealing. It's a really interesting result. And that's with the max load, right? So one of the most amazing things about the results shown here was the fact that the primer pockets held up perfectly. Through all 76 firings, we did not have any noticeable lessening in primer pocket seating force and no signs of primer pocket failure. Primers were retained and the primer pockets held up perfectly. What can you expect with your brass? It depends on your setup. If you're annealing each time, we're using the Annealing Made Perfect Mark II DB here, that's going to help tremendously. It's also going to help with consistent neck tension and consistent shoulder bump, so consistent and easy setup for your sizer die. We made sure that we were pushing that shoulder back not more than about 1/1000th of an inch, right? Very minimal working of the brass, however much, you know, we could control that to whatever extent was possible, right? So this is yet another experiment where we see the value of quality brass, of quality components, and very meticulous attention to detail. And I've talked to some people that have gotten similar results with Alpha Munitions brass, right? With annealing and with max load type firing. So it's pretty amazing to see. And so, you know, what we want to do is to continue to run some experiments like this that will help us further understand where the limits are and how far that you could push different components and rifles and that sort of thing. The experiment where we pushed 6 GT to 6 Creedmoor velocities, we had, for the first time ever, actual live pressure measurement, case mouth sensor, a porthole, and a PCB piezoelectronics sensor, and a Series 8-channel data acquisition from Duosoft. Really high-end gear, and very interesting to see the results unfold in real time. So what we're doing now is we're looking at, hey, what's our next experiment going to be? So you're going to want to stay tuned for that. What I'd like to know is, what do you think about the results that we got this time? You know, does this seem feasible to you? Have you ever seen something like this? What kind of results have you gotten with repeated firings, maybe with or without annealing? Please drop a comment and share your experiences, and we'll start that discussion down in the comments section. Thank you very much for watching. That concludes this video, and that means it's time to wrap it up. I hope you enjoyed this video. Don't forget to like and subscribe. Also, we're on Facebook, YouTube, Rumble, where we've got unrestricted content, and Instagram. Make sure to follow us on all those channels. Ultimate Reloader also has a commercial solutions division serving law enforcement, the military, and the gun industry. We have some unique capabilities, including a comprehensive suite of recoil testing and evaluation capabilities, trigger profiling, and more. Thanks again for watching.